Hello everyone, welcome. Hopefully you've watched our other videos and have everything installed. And real quick before we get to our code, I'm going to give you a general idea of how Arduino is set up to run programs. So you have a space before your void setup loop, or your void setup command you can find variables, import libraries, things like that. This is, you're going to set up anything you're going to get any devices that you're using with Arduino started and set up and running. And then in this void loop area, you're going to use that to actually run code that's going to execute the task that you are looking to complete. So for us, it's reading from a scale and printing a number to a touchscreen. So uh, this is the program that you are going to use. And these are the libraries that you need to include to be able to get the touchscreen and the scale to work. And we have a couple of variables like this display number declared just so it's easy to read when we get down and do our code. And that's what all these defined things are as you go down. It's just so we can write black as opposed to writing a hex value number for that color. So as you're trying to do your buttons and layout, it's all set up to uh, be in something that's a little bit easier to read for people. And these are just setting things up. So we assign these pins to these functions, and we can just read this and know what's going on as opposed to being like trying to remember what is connected, what pin, and what's going on. Um, So we have some basic colors here that you can use if you want more specific colors. We have another set here. If you just highlight all of this and then you edit comment uncommon right here, it will make all of this code active again so you can use these variables and uh, set those colors. And then these are just some titles. So it was easier to understand what was going on as we were drawing the buttons and the text and the placement and uh, how far things should be in spacing. And these are some pin setups, just again, more things that are easier for us to read and know what's going on as we were trying to get things set up and uh, going. And then we have our declaration for our touchscreen, as well as all of our pins. So this tells the board how to communicate with the touchscreen so everything works. And then these are the variables that we use throughout to get things to work and change as we need them. Uh, the set scale value is something that will you get from a result of another sketch that is included, and you'll run that, it'll give you a value, and you're gonna overwrite this here. This is what we got um, for 0. That way everything works as should be. Um, and now as we get into that void setup loop, this is where we're gonna start. This is where we start the scale. We start the actual touchscreen. This is we use this for debugging. This all prints to this space right here. So this won't actually print to the touchscreen, so you don't have to worry about trying to read all of this on a tiny little screen. This will all print on the computer, and you can see what's going on if you start running a problem, see where it hits before you have issues. With the shield layout that we use, we didn't really run into any issues, so hopefully you won't need any of that, but it is there just in case you do. And then this starts the touchscreen itself, sets the rotation so it's set to portrait. It fills the screen in with black, and then this creates the buttons and draws them on the screen for the size that we want with the text and text color that we want. So that's what these are. And then there's a rectangle for where the number is displayed, and that's what this is. Um, and then this is for the scale to get set up. And this tells your scale what your calibration number is, so it reads 0 correctly, and then tears the scale so it's set to 0 to make sure that everything is working as it should. And then uh, this right here is used to define the min-max pressure, because we found the screen that we're using is a actual touchscreen, where you can press at different pressures and it can do different things, as opposed to kind of like your phone where it's just press or not. So it's a little bit different, but that's just to set the range. So if you want to change that based on how your students act, you can raise the minimum pressure so there isn't accidental presses, or uh, you can lower the max pressure to make sure that your students don't press too hard and go over that value. It'll actually stop responding. Um, and then this void loop is the main program that we're running. This is going to actually do the updates on the screen. This is going to be where all that stuff gets taken care of. So we have the current value, which is gotten from the scale. And then we check the scale for the units, so we're displaying correctly. And then with that reading from the scale, it can get very precise with the model that we chose. We found that it could go out like 16 digits, so we rounded it just to make it a more ruly number for students and you guys, so you have kind of more of a concrete, this is what your bridge broke at, as opposed to trying to give out these massively long numbers. Uh, so, and then based on the units, have a conversion between pounds and kilograms. And then this is used to set the color of the text to make sure it's the right color as things go through for the actual display. And then this will show max load, or the current value, or the current value if it's the units toggled. It'll also show the correct units. And then this is just giving feedback to the screen to know where to do that. And then this is just to, again, tell the screen what to draw where on what pins. And then this basically asks if it's going to register a touch and where that touch is on the screen. So you know where the students have pressed. So if they hit a button, it knows that down here it'll change if the student press button, it'll register as true. If not, it'll stay as false. And then what we're going to do is release all the buttons so we can read their states. And then we go through and basically check if each button has been pressed. If it has, so the reset button, it'll reset and set the max load back to 0. If the units button, it'll change what units are being shown with the value. And then the current and max button, it'll switch between the max value, your max value, and the current load. So that way you can see exactly what force the bridge broke at, so you can give that number to students uh, without having to worry about like trying to read it as it's breaking and being that close. Gives you some safety distance to make sure everything is fine. And then the delay is just so as the Arduino runs through this, it's going to hit the bottom and then it's going to go back to the top and keep doing that. This delay is to make sure all the signals have been processed throughout this to make sure that there is nothing happening that shouldn't be, or buttons aren't getting cleared correctly, or uh, not being registered as being pressed. So that's what this helps with, is making sure everything runs smoothly. And once you hit the end of that, it's going to bounce back up to this loop and start all over again. It seems like it's doing a lot, but the processor on the Mega is a processor within the megahertz, so it'll actually run all through this several times in under a second. So you'll have a very accurate, updated measurement for students to test with and make sure everything works. Uh, and you don't have to worry about uh, things happening in between. If, let's say, a button gets pressed down here, uh, it'll just catch it on the next time through, which will be almost instantaneously, so everything registers and works correctly. Um, we will include resources that we used, so if you want to change things or uh, improve them, feel free to. That way you can kind of customize things and make it your own. Hopefully this video was helpful and you enjoy testing your students' bridges.